Welcome, everybody, to the American Space Museum. I'm Marquette, and we're so glad you're with us on this episode to Stay Curious. Today, we've got two payload specialists with us. Meet Mr. Damon Nelson over there. Hi, Damon. How are you?
Be here, Mark.
Well, we're glad to have you here, and you Stay Curious watchers are familiar with Mikey Haddad.
Good to be
over
back,
there.
Mark.
Hey, Mikey.
Good to see you, sir.
Mikey pinch hit for me as guest host at the beginning of the month. Thank you for doing that.
Welcome.
I know it wasn't exactly your cup of tea, but
I'm glad you're back.
Well, good. You did a good job with Marty helping you along the way. These two gentlemen are what they call level 4 payload engineers, which is, I guess, the highest engineering level you achieve. Is that right?
Well, level 4 is actually the location and the group that was the name of where we work. But
Okay.
Yes,
well, throw that out. I thought it had to do with the level you achieved. But they worked on our fabulous space shuttles in that golden 30-year era where we changed the world and set us up for the 21st century and the International Space Station, doing things that a mission like they're going to talk about today in 1984 set the groundwork for, right, guys?
Yes, sir.
So we want to learn a little bit about Damon Nelson over here. Damon, tell us a little bit about where you grew up and how many years you gave your life to our shuttle program.
Well, I grew up in Titusville, Florida. I was what I'd call second generation. My father came down with the Apollo program in '63. I took the reins in '79, putting tile on Columbia, and then I did an internship for 2 terms out at JSC as a NASA intern before I came back to Florida to work full-time for NASA. I started working the shuttle directly as an APU systems engineer, but shortly thereafter I switched over to the group that Mike worked with, the Payloads group, and which we're going to talk about one of the experiments that I had the privilege of working on, called the orbital refueling system, and I spent about 37 years with NASA. So worked a number of years with the space station, and the end of my career has been involved with the Artemis exploration program.
Wow. Well, you had our viewers know that we consider you a national treasure, along with Mikey and my co-producer Marty Winkle. Hey, Marty. We took Marty's microphone away from him today, because we have it on our set here, but we're serious about that. What you folks did doesn't translate into a regular society job outside of the space industry, and we appreciate all that you did. You brought a little show and tell with you here. Hold that up there.
Oh, sure. This was an old procedure that I found. It's about a 40-year-old document that I drafted for the servicing operation we did on this experiment, again, called the orbital refueling system. It was a complicated assignment because it involved monopropellant hydrazine, which is an extremely flammable commodity that the shuttle used for the APUs and the SRB HPUs.
Mm-hmm.
So it was quite an interesting challenge for me.
Well, we got a great program they put together. We're going to see you guys in escape suits. You're going to learn what a escape suit is, okay? We're looking forward to. We're going to focus on 41G, all right, in 1984, and we'll talk about that in a minute here. But I just want to say hi to Mikey. How you doing?
How's good, sir.
How's the? I was in Ohio and Tennessee to see some fall foliage.
Oh, okay.
But you wouldn't know it's fall here in Florida, would you?
So we do the same thing. We try to go through the Midwest to see the changing of the leaves.
We're back to t-shirts and shorts around here now.
Yep.
Yeah. So eat your hearts out there, Dave Stange up in Michigan, and all of our friends around the country. We got a couple housekeeping chores we want to take care of before we turn loose on our payload specialists here, Mikey and Damon. We are having a memorabilia show November 5th at the Hotel Holiday Inn, exit 95, $30 a table. Ken Havicott Memorabilia and Bid Again Auctions are sponsoring it. We want to raise $5,000 for our galleries here. And we are having a unique auction at 4 o'clock Saturday, November 5th. I'll be flooding our Facebook, and we'll be talking about it all next week. But we're going to auction off 12 items, and they're going to be good items too, from $200 to $400 to $500 items. Things space flown, a shuttle that we've got 20 astronaut autographs on, and we'll be talking about that. So if you can't be here, come support us. We're having free appraisals there too. But we got a birthday. Damon and Mikey, we love celebrating the birthdays of our shuttle heroes out there. And today we got Steve Robinson's birthday. All right. And I didn't get his birthday printed up there. Let's see. Where was Steve Robinson born? I need to figure that out, Marty. There's Steve Robinson in the cupola. I'm going to duck out of here a second. Let me see something real quick here.
It's a great picture from inside the cupola.
Okay, Mikey, talk.
Mikey, tell me, tell us a little bit about what you're going to talk about, the Mission 41G.
Sure. We're going to be talking about, there's a number of elements that flew on this mission. We'll focus on 3 of them, which is the OSTA 3, which is the Office of Space and Celestial Application 3 mission, a large format camera, and ORS that Damon had mentioned earlier. Those are the 3 we'll focus on. There's other things that flew on this mission, but those are the 3 main ones at the level 4 that Damon and I worked in. We'll focus on those because those are the ones worked by us. Again, back in the mid '80s, a lot of fun. We were both a lot younger back then, but it was just, it's going to be a fun mission because there's a lot of interesting things that happen with this preparations of these elements that then rippled into future elements or future missions, and things we learned while putting this hardware together really impacted and was able to cause great changes in future missions to save a lot of problems that we avoided, try to avoid all the problems that we had on this.
And an all-star crew filled with a lot of firsts I'll tell you about here in a minute. Now we're going to have happy birthday to Dr. Stephen Kern Robinson, born on October 26, 1955 in Sacramento, California. He's been on 4 space shuttle missions. But the coolest thing he's probably done is to be the lead guitarist for the all-astronaut Max Q band. All right. Did you ever see them play, Damon?
I did not.
They always play at Johnson Space Center.
Yeah,
they don't
right,
come to
right.
They don't come over here, do
Right.
Well, they played a couple times at our KSC picnic.
And
Annual picnic, they came down a couple times for that, but not many times. But
they? And were they good?
Oh yeah, very good. Everybody sang good. Very good musicians. Yes.
Yeah, this is an outstanding musician. He can play bass, banjo, mandolin, pedal guitar, cello even. And we're talking about Steve Robinson, born this day. Happy 67th birthday to him. He spent 48 days in space, wearing a cool Creature of the Black Lagoon t-shirt there. He's got to be a character for sure. 4 missions, including STS-95 with John Glenn. And then he went on the return to flight, 114, a big event. And his last flight was 130 when they put up the cupola. And there he is rocking out with one of his Fender guitars on the Vomit Comet. I would say where that's at. So happy 67th birthday to Steve Robinson. I'd love to hear his story someday out at Kennedy Space Center. Well, we're here to talk to 2 payload guys. And Mikey has written this book with David Shaler. We interviewed David Shaler in his European home. I guess he's in London or somewhere.
UK.
In there. And there's your book there, Mikey.
Thank you, Mark.
And you want to order that on Amazon Smile. So your favorite nonprofit, the American Space Museum, gets credit for that. A Springer publication. You sold a few of these, right?
Yeah. Well, right now we got about over 2,000 electronic downloads. Not sure how many hard copies. We'll find that out at the end of the year. Yeah.
Excellent. Good. Well, Goodest doing good. And this is where we're getting the meat of your talks is from that book on there. And we celebrate the shuttles of the month. All right. 12 payloads, 12 shuttles in the month of October there. We've talked about this throughout the month. Guys, Pam Melroy has 3 of her 4 missions in October,
Oh my gosh.
including
Wow.
her command
Okay.
there on STS-120 over in there. But we're going to talk about the second one in the calendar month up there, launched on the 8th of October, the 5th of October, 41G. And here's the mission insignia for 41G, the chevron of the astronaut pin there. This is filled with a lot of firsts, and here is the wonderful crew. The 13th flight of a space shuttle. 41G was the first mission that focused almost entirely on studying the Earth through the use of a satellite, multiple instruments, and cameras, as well as the crew's observations. Commander Bob Crippen became the first astronaut to make a 4th flight above the shuttle, only 5.5 months after returning to space from his previous mission, 41C. So he's the first American to make 2 trips in space in a calendar year for the great Bob Crippen. He just had his 86th or 87th birthday a couple of weeks ago.
Awesome.
Yeah.
Pilot was John McBride, making his only flight to space because he got caught up in the Challenger explosion and was going to be a one-time pilot and then a commander of a mission. John McBride was the chief astronaut at Kennedy Visitors Complex for many years. 3 mission specialists, Kathy Sullivan and Sally Ride and Dave Leesma, the first time 2 women had flown in space at the same time. And Kathy Sullivan was going to do the first American woman spacewalk. And then you have there Mark Garneau, first Canadian in space, Paul Scully Power, a civilian employee of the U.S. Naval Research Lab and the first oceanographer to go to, and the first Australian-born American to go to space. I think Garneau, or Scully Power, is also the first astronaut to go to space with a full beard. What do you guys think?
Could be, yeah, because a lot of them are clean shaven almost.
Yeah.
Yeah.
And the first 7-member crew. But we're going to talk about the Earth Radiation Budget Satellite, something called the Office of Space and Terrestrial Applications Cargo, and how to fuel a spacecraft in space, as well as the 900-pound large format camera. So, guys, I'm going to turn it over to Mikey and Damon here,
Okay.
and take it away.
Alrighty.
Tell me when to show to the next slide.
Okay, yeah, this is kind of a cargo layout of everything that flew on this flight. You can see there's a lot of stuff that flew on 41G. We'll focus on the OSTA 3 kind of in the front part there, and then the LFC, MPES, and ORS that's in the very back. Those are the 3 main elements that we in Level 4 had focused on for this flight. So I just wanted to kind of show there's a lot of stuff that flew on 41G.
Absolutely, and to throw a spacewalk involved in that. So
Yeah.
very busy crew for their duration in space.
Yes, sir. Okay. All right. This is focused in on just the OSTA 3 itself, large Serbian antenna, which again it's kind of it's a lot like Mark said that on the imaging things of on the Earth. And so this is basically a breakdown of the OSTA 3. You can see again it's a lot of hardware on here. And the reason I wanted to show this was that, again, we did a lot of integration of this hardware onto this pallet. Again, it was a standard space lab pallet that you shape, and then all this hardware kind of goes on it. So
that's right behind us on our green screen there,
Yep.
Mikey, right?
Yep. That's the on-orbit image, yep. Of what it looked
Over
like.
there on the left-hand side.
That's why I wanted to kind of show kind of a graphic of everything that was on there we had to put on, and of course you'll see the actual flight house. Now, what this is interesting. You can't read this.
Yeah, somebody's chicken scratch.
Yeah.
There. Is that yours?
No, it's actually George Vaudry, who was working the fluids for this mission. But what this is this on the pallet, where all that hardware you saw in the previous image. This is a cooling loop to keep all that hardware cool. Basically, we would use Freon, like Freon in your car. We'd use the Freon 114 to keep all these instruments cool. Now, for us, we basically did about the 2/3 on the right. That was what our responsibility was. The 1/3 on the left was McDonnell Douglas. But basically, every circle you see on that thing is basically a connection. And if you want to look, kind of, you can see like the hard lines are basically straight lines. Kind of the squares and rectangles, those are cold plates that the instruments actually sat on. And kind of squiggly lines, those were hoses, like a garden hose. So basically, everywhere you see little circles, a connection. Okay.
Wow.
When we put this thing together, we had to leak check each of those connections. Okay.
There's like 36 connections there.
A lot of connections. Okay, and the kind of way we did that was we would use helium. And again, operationally, you wouldn't want to try to put one connection together, pressurize, check that connection. So we put the whole loop together, pressurized it with helium. Now, why helium? Of course, helium's a very small molecule. Okay, if you're going to get a leak through that interface, the helium molecules
It'll
will
sneak
it'll-
through
it'll
any
sneak through.
smaller hole. Okay.
Right. Now we had a spec that you could have a little bit of a leak, and that was okay. So there's a spec that we had to follow. You're below that spec, it's good, you can fly. If it's above that spec, you had to fix it. Okay. And again, because of Freon molecules are a lot larger, that if you seal it with helium, it's probably gonna be sealed when you load it with Freon.
All right.
And I wanted to share that. Okay. Now what this is actually a representation of two of the types of hardware used. Now the AN fitting was a lot of the hardware that was used on this flight. And what it is basically that's kind of one of the mechanical fittings. And on there, when you put a hose on, you actually had to put a metal seal to actually seal that interface, and you tighten it down. And what we do operationally is there was a torque range. Okay, so we'd go to low torque, okay, and pressurize, and hey, is it sealed? Good. We don't have to do anything with it. If it didn't, we had to go to middle torque and high torque. Now, how do we do the leak check? There was this large machine called a mass spectrometer. It's basically sat on the floor with a meter, and a big hose that ran up into it. And basically what it does, it sensed helium. Okay, so if this connection leaked, the probe that they would go around that interface with would sense that helium, and the machine would pick it up and say, hey, you got a leak. Okay, and we had to do that for each connection. Okay, so it was a lot of work, but it was what was needed to be done. Now, what we found out is these AN fittings had this metal seal. Well, we found this other fittings called MS&MC, which were a lot. You can see from the picture here, one's kind of dull, the AN's kind of dull. The MS&MC are real shiny. And so we basically, the ones on the right were the ones that would leak not often at all. So we always pushed to go with those. So in future missions, when we review the drawings, we saw AN fittings as part of their Freon cooling loop. We'd say, nope, change those because those leaked a lot. We had a lot of problems solving the leaks on this hardware. So we basically comment on the drawing, say, use the MS fittings, it'll save you operation. Of course, they're a little expensive, but it would operationally was the way to go. So this is one of the lessons learned. Hey, we learned early on the AN fittings, they really leaked a lot. It caused a lot of problems. Please go to these nicer fittings, and that helped a lot on future flights.
And this is the 13th flight of a shuttle,
Right.
so and
This is
not
early
all
on.
of them flew payloads like you are, so you've got some experience there. Are these an inch or 2 inches, or kind of small?
Like
things,
the diameter, yeah.
So anybody's messed around with fittings like that with hoses where they clamp on a car?
They thread on, just like you would.
Okay.
Yeah, and the thing too is, again, like this, we didn't want to have leaks because, like in your car, you lose your Freon, your car gets hot, right?
Right.
Well, we lose Freon in orbit, you start burning up multi-million-dollar instruments, and we did not have that happen. So that was kind of wanted to show this is kind of the hardware that we had to deal with to fix.
Question: would this be something that you go back to the manufacturer and say, "Look, we flight tested these. We need for you to do this little tweaking of it"?
We did suggest that, and they said this is basically the way the AN fittings are made. And so, if you want better fittings, you buy the MS ones. We couldn't get them to change how they actually made the fittings because that's what the spec called for.
Okay.
But for us, again, we just changed the hardware and went, okay, so once we get all that hardware together and leak checked and everything's good, basically we pass all the specs. Now we start putting the hardware on. And this is a picture of the Serbian antenna going on. The gentleman standing in the middle with his head going up, that's Greg, or forgot his name. Greg Hale. He was one of our Boeing techs. And our engineer that was actually in level 4 that was responsible, he's kind of in the background. It's hard to see him. He's got a beard and mustache on the back right there. He was our Luis Montezuma. He was the gentleman responsible for not only installing the antenna, but doing a lot of alignment. Louis was our level 4 alignment genius. On future missions, we'll talk here on Stay Curious. He was essential in alignment for some of his future flights. But this is, again, one of the early ones that he worked on. And I just wanted to show a picture of the hardware going on to him. Actually, the antenna being installed. Again, this is all done in the operations and checkout building on the west end of basically the level 4 area where the name comes from, of the ONC building. All this work was done horizontally. Yes, sir. Okay.
All right, good. We're talking with Mikey Haddad here and Damon Nelson, both payload specialists, engineers that worked on 41G. We're grateful to Doug Forrest. You're watching on your lunch hour in Los Angeles. Dave Stangy's up there. He probably needs to rake his leaves this evening up there in Michigan. As William Whiting's also another Michigander up there. Humberto Villada Lopez is watching. Melissa Popes at the Office of Space Coast Tourism here on Cocoa Beach. We've just had some phenomenal Chamber of Commerce weather, haven't we, Melissa, here the last few days? Mark and Tom Usiak in Lancaster, Pennsylvania, maybe enjoying a shoe fly pie for a snack. I don't know. They brought me one back though from Lancaster, and I think I'm pretty good on shoe fly pie for 6 months or so, guys. We got at Kia 12 and Nick Palladino.
Oh, Nick Palladino.
Nick Palladino.
He's a level 4 guy. Hey,
You know
Nick, how you doing?
All right,
Yes.
Nick, thank you for staying curious there. All right, guys.
Welcome, Nick.
So
Welcome, everybody.
let's rack up the next picture here.
Okay, this is just another picture of the OSA 3 hardware. You can see the technicians in the full bunny suits again. A lot of integration, a lot of hardware went into this OSA 3 payload. It was done basically in level 4 area by our level 4 engineers and the Boeing technicians.
I'm reading the sign there. Your signs are always interesting to me, and it's got on there the number of personnel on pallet.
Yes.
So you need a sign to tell you that you have too many people on the pallet. Who counts them, Mikey?
Well, usually we kept track of that. Yeah, I made sure that okay, if there's 4 and you need somebody would come off and the other one would go on and maintain that number. It was just something that was basically for visitors.
To get
For people that came, like say the OSA 3, just for that mission, they try to learn a lot of the rules, but there's so many rules at Kennedy, so we put these signs up. It would be easy for them just instead of trying to read this and memorize it. The sign would be there for anybody that's kind of visiting to say, this is kind of what you do, what you have to do when working on this hardware.
Talk to Damon here a minute. What I find interesting, Damon, is that this equipment was built to work in space.
Correct.
So you couldn't stand on a lot of stuff. You had to have scaffolds and pallets there because it was too weak for Earth's gravity. It was designed for space, right?
Correct.
Mm-hmm.
Correct.
You remember anything?
Well, some of the equipment they did take into account that people would work on it, on the Earth. These pallets that were developed by the Europeans, they knew people would be working on those pallets. But the equipment that you see here, the Serbi antenna, obviously that was built purely for a space environment.
Yeah, I find that interesting and constantly remind our stay curious people out there. Marty Winkle worked on the lunar module for Grumman, and you could not walk up and down the ladder on the leg of a lunar module because it was designed for 1/6 gravity. And if Marty stepped on it, it'd break.
Right.
Here. So I always want to remind people, when you see situations like this, there's more than meets the eye there
Right.
for your safety as well as the integrity of the equipment you're working
Because a lot of this stuff, there's only one like it on the planet.
Right.
And if you damage it,
One like it on the planet. I like that. And here's 2 guys that have worked with these unique items.
yeah, what this is kind of a pulled back view showing the level 4 area. And what I wanted to show here was this, kind of in the foreground is the cooling unit that was used to keep all this equipment cool. Once all the hardware went together, we started testing. This is kind of the layout of the green, kind of on the right there, and then basically all the stuff in front of the yellow scaffolding was a cooling unit. That our techs, and if you can see up kind of off to the top, is the OSA 3 payload. What we tried to do is we tried to configure these elements the way they would be in the shuttle. And so I just wanted to get a pull back view because usually we're up close. So this is kind of a big picture view of the area that we worked in. And then the next one I want to focus in on is we had 3 people that were just amazing. They had to take this monster, and you can see all these hoses and gauges, this dinosaur equipment, and get it to work. And these are the 3 people that worked on it. The person on the far right is Gary Bittner, Boeing Tech. The engineer is one of the mechanical engineers, Debbie Bittner, in the middle there. At first, they weren't married, but they ended up getting married later on. We had a lot of marriages that came out of level 4, and I need to say they're still happily married today.
Well,
Yeah, and so she was the
an
engineer.
engineer finds a mate or
Yeah.
a mate for life. Huh?
Yes, I sure did. Yeah, and then on the far right is Bruce Birch, and these 2 guys were geniuses when it came to air conditioning systems, and so they had the task of trying to make all this work, and they did.
Yep.
It was a lot of work, but there again, I think we had some of the best techs on the planet, and they worked for the Boeing Zeiss Corporation at that time.
Yeah.
So I just wanted to kind of talk about one element of this that was just amazing work that had to be done just to make sure this equipment could be tested before flight, and all this had to go in to making that happen before we could ever get in space. Yeah.
And you could not test it where it was built because you needed all the elements of the the payload bay and so forth.
Yes.
To integrate it.
Yeah,
The word integrating.
Yeah, the other instruments would be off wherever, and they would do the local testing. But then, when you integrate all this together, like you saw on the pallet, and all that has to work, that was kind of our job.
Mm-hmm.
Yes, and so you're right. It was tested off, but then we had to do the integrated testing. So I just wanted to give a kudo to them because they did a super job on providing cooling to keep all this stuff working while it was on the ground. Yeah. Okay, now this is the next one we're going to talk about. It's called large format camera. It was a huge camera that flew in the back. There's actually another element kind of off to the right there where they had, this is the main camera with the door, the big rectangle door there that would open up and they would take pictures. And then the kind of off to the right was a attitude reference system. It told the camera kind of where it was pointing. And one thing interesting about this camera, it's called large format camera. Remember back when you had the 35 millimeter film?
Yeah.
The negatives were about this big?
Absolutely.
This is a single negative from that camera. Each negative was 9 by 18 inches long.
I'll show that up here closer. As I get this up here closer.
That's the size of one negative.
The size of one negative, and that's a very familiar.
In fact, I'm in that picture.
Yeah.
I'm in that picture when the PI was going to, I get a call.
There's our Space Coast
Yep,
right here.
right in there, yeah.
Yeah.
I get a call. The PI says, we're flying over Kennedy Space Center. Go outside and look up. Because I'm in that picture.
So you're in that picture.
So yeah, I'm outside looking up and people are looking, what is wrong with you, Haddad? They're going over
PI. The PI is the public
principal investigator.
Oh, principal
The
investigator.
gentleman that was in charge of the camera, basically. And so,
Okay.
but that was something I wanted to show. It's
Yeah, that's
amazing.
pretty cool.
Now, there was
Yeah.
2,400 of these negatives, basically made up a roll of film. So the roll of film was 3,600 feet long.
Wow.
It was
You got
in
the,
that
the negative marks on it
Yep.
there.
Mm-hmm.
And the bigger negative gives you what?
Well, you can zoom in.
Better resolution.
A lot of resolution. In fact, I want to talk about one of the images they took was over Boston Harbor. Beautiful image of Boston Harbor, but halfway through it was a scratch. It's like, oh, they damaged something happened, and it got a scratch on this image. Well, they zoomed in, and it was a contrail of an airplane. It was not
Oh,
a scratch.
really? Oh my
That's
gosh.
the detail that this camera was able to see. Yeah.
That's interesting.
Yep.
Down there.
So I just want to talk about that. That's one of
A
the
big instrument, and Damon, we were talking about that this photography, not this instrument, but another one, discovered some ancient remains of a civilization.
Yes, yeah, the radar imaging. What it is it could actually image through the surface and down past the surface, underneath the surface, and they were able to find things that were buried in the sand, basically.
Which was one of the really unique features of shuttle payloads is they could be reused, and there were many examples of shuttle payloads that flew on this mission that got an opportunity to fly on a future mission because we could bring them back. We didn't have that feature with a lot of the Apollo missions because they could not bring it back.
And if there's a little space in you people would know what was the assigned payloads and say, hey, you got some space in there for this large format camera or whatever. Is that kind of how it worked?
Well, yeah, they would determine the configuration ahead of time, yeah, and then they would come to us and say, okay, can you put this together? And so, yeah, the decisions on what would fly there's a huge process on what actually flew in space because it was a lot that these people had to go through to be able to get this hardware certified to fly in space.
Marty, we have a question.
Yeah, Mark Usiak is asking, was it specialized Kodak film, color negative, or transparency?
It was a bunch of different films. In fact, I go ahead and I wrote them down here. It was Kodak 3412 and 3413 was the black and white. There was color infrared. So that was the three different kinds of film that made up this.
Infrared would make sense.
Yeah.
You get a heat registration.
Yeah. So that was good. Very good question. Yeah, that was different types of film that made up the 3,600 feet of it. Yeah, good question.
Different canisters to put in. Well, it'd be all automatic because then and it was film, folks. In
It was film.
1984, film, no digital, silver halide on a piece of plastic,
Yeah.
smeared on a piece of plastic,
Yes, sir.
basically there. All right. Well, we got another.
Okay, next one. This is the orbital refueling system. That and the large format camera flew together. You see the kind of the structure in front there with the big X's on it. That's where the large format camera sat in there eventually. What this is a picture is of the orbital refueling system. that Damon was specialized with. This is the installation in the ONC. I'm on the far left there. That's me with the hat on and all the hair that is gray. But that was basically my responsibility. Basically, was integrating all this hardware together. And then Damon, of course, was responsible for the fueling ops, which is very, very dangerous, very hazardous. So I just wanted to show a picture of us installing ORS for flight. This, again, was the operations and checkout building. This is one of the tasks we had to do. And this is a great picture of that happening. Okay? And then from here, I want to turn over to Damon, where he had the pre-flight stuff maybe that he had to go through, and then talk about the spacesuits.
Yeah, sure.
We got 3 marshmallow men there, or women. There could be a woman in there. What are we looking at, Damon?
Yeah, sure. That's what we had to wear. The propellant, and it really was a referee fluid for this mission. We didn't burn any propellant per se. It was just demonstrating a transfer. This was one of the earliest demonstrations that NASA performed to actually prove the concept of refueling satellite or an on-orbit spacecraft. And the neat thing about this mission or this project was we were able to utilize excess hardware from an earlier system called the auxiliary power units that were developed out at the Johnson Space Center. The NASA Johnson folks took the lead to develop this orbital refueling system using a lot of that equipment. And our role at the Kennedy Space Center, again, the NASA Level 4 team had the responsibility of taking this equipment and integrating it, as Mike had mentioned, and then we had to fuel it for launch. And that was an interesting challenge because the facility that we had to use was out at the pad. And so our safety engineers determined that because this propellant is so highly flammable, they wanted the entire pad cleared for the fueling and pressurization op. So it was a 24-year-old engineer. That was a pretty daunting and intimidating task, knowing that you were out at the pad, you and our Boeing technicians, all by ourselves for about a day and a half to get this thing fully loaded and pressurized. We used those escape suits because that allowed us to stay safe. It allowed us to keep any of this propellant in the event of a discharge, from inhaling that propellant, which could do great damage to our bodies, our lungs, such not. So
Escape suit. What's that an acronym for? We have one in our shuttle, not our shuttle, but in our
Let me see if I can remember.
workers gallery here.
Self-contained apparatus protective ensemble, I think is what it stood
yep,
for.
I think you got it.
I think
Yep.
that's
Marty,
Yep.
self-contained apparatus protective ensemble.
Yep. Very
I
good.
think that's what
Wow, they got an acronym out of that.
That's why we'd always talk acronyms, because you couldn't remember what
I
it
said,
was.
I look at Marty because Marty was Marty in the Apollo era. You said you wore a escape suit like these, right?
Yeah.
And see, what's neat too was the escape suit. Well, to get from where we needed to go to where the payload was, in the suit you'd carry like a small diver's bottle full of air.
Mm-hmm.
You'd carry that, and once you got to the facility, you would unplug. If you could see the center gem, it's hard to see, but there's actually a facility airline. So you have air coming from the facility. So you have this airline that's following you around, pressurizing the suit. Yeah.
And they had
Sure makes a fashion statement there.
They had 2 versions of it. They had a self-contained version, but we preferred the version that had an air hose that allowed us to stay in them for much longer, because
Okay.
we could feed off of facility air using that approach. We had a team of 4, and that team was going to be comprised of a combination of Kennedy Space Center folks and Johnson Space Center folks, because they had had the opportunity to practice this procedure out at their center. Unfortunately, they were not able to pass the physical that was required. Again, being where we were located, in the event of an emergency, there were many, many flights of stairs you would have to go down to safely egress. And so we ended up ultimately with just the team of young KSC technicians, engineers. I ended up staying for multi-shift operation. Mike was going to be my backup, but we were delayed such that it was decided that I would stay in the whole time. So there was this urban legend that I had been in a escape suit longer than any other person, but we've never validated that assumption. But that's a long time to go without food or water.
Because
for
normally
sure.
I think the two.
You didn't have water either?
Yeah, no,
How long?
food.
How long you
It was
talking?
a couple of shifts. Yeah, it was a pretty long time.
Like 16 hours or something?
It was greater than 12. Yeah.
Wow.
Yes, not recommended.
Well, why wouldn't you be able to have
Well,
drink?
again, you with that suit on, there's no way. I mean, you would have had to pre-stage water, and even then, it would be
Yeah.
very difficult to try and drink
Wow.
or eat. So it was a long day.
Long
It was
day.
a long day, but
Do
it was well
you
worth
get,
it.
do you get hazard pay? And I mean that sincerely. Is there a extra pay
That's
to
a good
put this
question.
on?
If there was, I never saw.
Yeah, we never.
Typical government NASA, right?
Typical government NASA, but yeah, so it was a great experiment. It worked well. It was part of the justification for Kathy Sullivan to do her EVA because
can see
one
that
of
in
the
the
items
picture,
was this quick disconnect that NASA developed to try and standardize any future potential of an on-orbit refueling capability. So she and
Dave Leesma
were part of that EVA, and we got great kudos from them upon their return that everything worked out as planned, and it was a very successful experiment.
Yeah,
as far as
this
we knew.
image here is amazing. It's my
Yeah.
favorite image ever. Because
Really?
it's actually a frame from the IMAX film The Dream Was Alive. They had an IMAX
Yeah.
camera on this. This is actually part of that film of The Dream Was Alive. This is a single image. And of course, you look behind it. What's down on Earth is the state of Florida.
Oh, okay, yeah.
All right.
Sweet, I do see
yeah.
that.
And of course, this is the two crew members heading back towards the back where ORS was in the back of the payload bay to do the EVA
Right.
work for this mission.
Damon, did Kathy Sullivan and Dave Leesma visit you at in the operations and checkout to see their?
I very much remember seeing Dave as part of the fueling. He came in afterwards and complimented us for the hard work that we did. I believe I had an opportunity to visit with Kathy at Johnson Space Center when they did the technical outbrief because she was one of the key individuals to tell everyone how it did. So yeah, it was nice to meet both of them.
38 years ago, folks, this was a big deal, particularly I would think to the Department of Defense that had some priority satellites, top secret satellites that they wanted to refuel. Correct?
I would agree with you. Again, this is something that
But they wouldn't tell us that.
this was early development. So, but I do know they were especially interested in large format camera.
Oh, really?
Yes.
Because of the images they could take.
Yes.
Yeah.
You got a negative
Yes.
9 by
Yeah,
8
right.
inches.
Yeah.
You could do a lot of that.
Yeah.
Yeah.
Yes.
10 Department of Defense missions that we're going to highlight one day on Stay
Yes.
Curious because I'm convinced the ones during the Reagan administration contributed to the Berlin Wall coming down. And but very interesting there. We've got
The next image. If you want to go to the next image, this
Yeah.
is basically them back actually doing work on the ORS. And kind of what it was there's a foot down on the bottom, very bottom. You can see Dave Leesman's kind of got his foot in it, and kind of it's like a place to hold his feet so he could do the work. And there was a shelf that they would open up and had all the EVA tools to do the connections that Damon was talking about. And this is basically a picture of them in the back of the payload bay, where the instruments go. And then of course you can see off to the left there's large format camera, the big camera, and then off to the side the attitude reference system. It was all part of that. Yep.
It's very neat there.
Okay. This is basically real quick. This is Serbian antenna being deployed. It was basically folded in 3 pieces, and this is part of the antenna being deployed during the flight. We just wanted to show how that was actually deployed, and then of course brought back and retracted to come home. Yeah.
getting back just for a moment to the refueling here, Damon, I want you to tell us a little bit about the tetrahydrazine, is it?
It was a
And
monopropellant.
This is not a hypergolic, is it?
It's a monopropellant,
Uh-huh.
and believe it or not, it's from a flammability perspective, it's much more highly flammable than the bipropellants. Monopropellants utilize a catalyst bed to produce their reaction, and I've seen many images. We had one shuttle return with a monopropellant fire in it. It was STS-9, and yes, it's a very dangerous commodity.
Where was that fire?
It was back in the AP. It was a ammonia spray boiler, I believe, back in the aft of the shuttle. Yeah, it was John Young's final mission.
Yeah,
And
right.
There was a
That's
lot of
the
puckered
space
people.
lab.
A lot of puckered people on the ground when that returned with that small fire. But yeah, it's a very dangerous commodity, which is still going to be utilized in Artemis with the HPUs that are on these solid rocket boosters. They'll still use that particular monoprop. So yeah.
I guess the question a space geek would ask is why would they use such a dangerous fuel? Why couldn't they find something else?
Well, it's a storable fuel, and it's a fuel that works very well in outer space. And that's about as far
That's
on the
the key.
chemistry
Yeah.
that I want to go.
Well, because it is what it is, basically.
Right, but
They
you can use it in a non-oxygenated environment.
It's
Yes.
got a lot of energy per
Yes.
exit weight, so it's
Yeah.
Very good here. Well, we're enjoying a conversation here with Damon Nelson and Mikey Haddad. Both are level 4 mechanical engineers at NASA, had a wonderful career working with payloads. Mikey has a book out called Space Lab Payloads. He wrote with David Shaler. And like we said, you can find Space Load Payloads on your Amazon Smile account there and support your favorite nonprofit, us, American Space Museum. Got a couple other pictures here to show.
yeah. This one's the post. If you want to post-flight one, if you want
Right,
to
yeah. And I just say before we get to post flight, you're getting the perspective of a couple of mechanical engineers. There was a whole team of electrical and software engineers that were also very instrumental in this mission that did the test and checkout with the shuttle systems that could not have been done until this hardware was integrated. But this is the de-integration. And again, the beauty of the shuttle was you could bring this stuff back and you'd have then an opportunity to fly it again. And this is some of the team that is hooking up the cranes to pull the hardware out of the shuttle post-mission.
That's Damon in the center in the tan outfit, the tan bunny. So that's Damon.
There, okay, that's cool. What a cool picture.
Yeah.
And, you know, I always like to ask about sights and smells. And was there any residual smell of space coming off this metal or anything that was peculiar to you? This is after the flight that was different from before the flight.
We had so much protective gear on and clean room garments, and the airflow in that particular payload bay was so significant. I don't recall smells, but I'm sure there were. It's just that I don't recall them. But it's a good question. But I know when we pulled this out, and this transpired over about an 8-hour period, and we brought it back to the facility to remove the propellant because we did not do it in this cargo bay. We wanted to do it in a safer offline facility. I remember Mike and I looking at each other thinking, gosh, a day ago this hardware was up in outer space, and here it is back on the ground. So it was a pretty cool moment.
Yeah.
Yep.
Yeah.
Pretty cool moment.
So it was a very successful payload. Yeah.
And you've got to share that many times with the payloads that you all have worked on. And
Yeah.
very, very, very fascinating.
You know, when I tell one story,
Okay.
Yeah,
the gentleman on the far right he was an engineer that was from
on
JSC.
the far right.
Well, after we got done with this, we got it all offloaded. We went to this place that everybody probably remembers it, Harold's restaurant over there in South Titusville. It was off
Okay.
behind Holiday Inn there. We went there to celebrate basically the end of the mission. And well, we're having fun and all that, and just, relaxing, and hey, it was done successful, we're offloaded, we're good to go. And the gentleman that was there, he says, well, aren't you heading home? Oh yeah, I'm flying home today. And it was like 1 o'clock, and he goes, when's your flight? I go, 3 o'clock. I says, you need to leave right now, because it's like, you need to get to the airport and all that, turn their learning car in anyways. So he takes off. Okay, well, a couple of days later, we call his office to see, hey, did he make it okay? This is before cell phones or anything. Oh no, we thought he was still at the Cape. We haven't seen him. And so we thought, oh no, because he was rushing, either got pulled over, he's in jail, or he's in the hospital, he got in a wreck. So we tried calling him, we called every hospital, the police, no, we don't have any description. Finally, about a week later, he calls us. He says, where have you been? And he says, because of the stress of the job, of the mission, of the deservicing, he says, I just needed a break. And he took off. He says he went, I guess, into his cabin for a week, and he just got away from the planet for a week, didn't tell anybody. Turned out being fine, but it's just one of those things, one of those stories where, hey, this guy had worked so long and so hard that when he got done, it was just like, I just need a week by myself. And so it's just a good story about him. He's a good engineer, kind of a laid-back guy. Talk kind of real slow, real brilliant guy, but he's just kind of real laid back, and you could say, I can see him doing that, not telling anybody, they don't care about me, and taking off for a week, not telling anybody. So that was just one story. One of the many
That's a good
stories
story about, there's and the story for me is how seriously you all embraced your jobs, how you got what you were doing was either part of our defense of our great country or moving our great country forward in science and technology.
Thank you.
Right?
It was a lot of fun. Had a lot of fun. Best years of my career.
We hope Angela Butlers enjoyed this episode of Stay Curious, and Denny Noah's watching. We appreciate that. We've got kind of an interesting picture here to take us out. Another weird suit.
That's
you guys are in.
just another version of the skate suit. Yeah, and again, you had to be a little bit careful because you could get disoriented. The airflow was very loud. It was very hard to communicate in those suits. We did have microphones, but it became very difficult at times to be able to communicate. And so it was something I'm glad I did once, but not
Is
sure.
that you in there?
I'm not sure.
Oh,
No, it's a random picture that I was able to
Yeah.
find. It's
But-
called the Cat 6 skate.
Yeah, but we've got technicians that basically risk their lives every day in those suits, dealing with these hazardous propellants, and we all take our hats off to those guys for sure. Yeah.
Yes, we ought to do a Stay Curious on some of these propellants.
Yeah.
The hypergolics
Yeah.
particularly are very dangerous. We've heard
They're
stories about
really-
an eyedropper full of it going
Yeah.
through a table and could go through your leg at the same time.
Yeah, in fact, when we were doing deservicing, we had one of the techs got his face sprayed with it, and so we had to wipe off his, luckily he was in the suit, of course. So we just had to wipe it down, and then of course afterwards they had to come in with all the probes and all to make sure they had residual propellant in the room, which they did. So it was very successful. Deservicing. And then this is the last one. This is a site, again, I try to show this every time we come on the show. This is a site where, again, Maynette Smith, who was here earlier, she kind of developed this site. And this is the one where we want people in the site, the URL.
SpaceLabPayloadPeople.com. SpaceLabPayloadPeople.com. You got a picture there you'd like for you to share it and that sort of stuff?
Well, this is actually a site where we want anybody who works Space Lab to go to this site and tell your story. Okay, that's what this is for. Is you go in here and you type everything you want to type. This is what I did on Space Lab. So it does two things. It'll let people who worked on it tell their story, and then people that want to learn about Space Lab can go to this site. So that's we've developed that. So it's kind of a follow-on to the book because you can only tell so much in a 500-page book. So there's a lot more information. So this is a place to go where people can tell their story and other people can read about those stories. Yep. I think that's the last one.
Yes, well, 38 years ago was STS-41G, and you guys were involved with the payload there. By the way, the 41G, this alphabet soup of numbers, the 4 is for the fiscal year 84. The 1 is for the launch at Kennedy Space Center. If we ever launched at Vandenberg, they were going to have a 2 there. And G is sort of A, B, C, D, F, G of the year payload that could get shifted around. More of Office of General Office Accounting is sort of what deemed this. And then after 51L, the Faithful Challenger, we went to the numeric numbers that made most sense to
Yes,
the
sir.
26. Hard to keep track of all these alphabet numbers, and then when you have people that don't know about the shuttle, they'll put 41G next to STS 41 in their filing cabinet, and you're like, no, that was one of the first 25 there, not
Yes,
later
sir.
on in there. But
Kind of confusing.
it is confusing, but that's why I bring it up to help demystify the alphabet numbers a little bit there. Guys, we really enjoyed having you on here. Damon, you're always welcome to come on Stay Curious. Hope you enjoyed the experience
Very much. Thank
in
you.
there. We feel it means a lot to bring the space workers on our program here, because obviously we learned some things about what you did. And man, does it seem like 4 decades ago, though?
No, not at all. Time has flown.
It's amazing. It's been out for 40
Yeah,
years.
well, it is, and to look at us, you guys don't look that old. but
Thank you, Mark.
yeah, they think you're in your 20s and 30s when you were in the infancy of America's Great Shuttle Program. Damon, how excited were you to be part of it?
Oh, it was amazing. I had lived shuttle for a number of years. I had put some tile on Columbia when it first arrived, and had those internships. And I'll never forget seeing STS-1 come back through the atmosphere and just thinking, never had seen anything like that come back through the atmosphere. And to know I had a part in that with the shuttle tiles, it was an amazing time. And we were very lucky. Our careers started with shuttle. We basically were flying our entire working careers. And, I feel sad somewhat for the newer generation, some of those people that have been slugging it out for a decade, and, they're going to get their opportunity hopefully here real soon with Artemis. But we were very lucky how we were able to, experience all that excitement pretty much from the get-go.
Yeah, well, it's such a vibrant time. You being a Titusville boy growing up here, did you go to astronaut or?
I did go to astronaut.
Okay, astronaut
Sure
high
did.
school.
Yeah,
Okay.
sure did. Yeah,
In
sure
there.
did. As a kid, I remember meeting Alan Shepard at a softball game once that my dad was playing in. So yeah, we were right in the middle of it. Yeah, we were right in the middle of it.
Explain to astronauts in high school. You said, did you go to astronaut?
Yeah, astronaut high school or the Titusville high school. There's 2 high schools there
Correct.
in Titusville. In astronaut high and then Titusville High.
Yep.
Titusville High is the Terriers, and you guys were the
War Eagles.
War Eagles.
Yep.
Okay,
Sure were.
in there. So yeah, it's just that. And you travel around outside of the Space Coast.
Correct.
What do you find the people's impressions of the shuttle in
Well,
your job?
Shuttle was very exciting at its time. It was amazing even up till the last mission. We had incredible crowds come to Central Florida. We really miss it, but I think it served us very well. It put a space station in outer space, and with the commercial launches that we're getting to see 2-3 times a week, I mean, it's a really amazing time right now that we're living through.
Yeah, it really is.
But a lot of us really miss those older days. And yeah, in my early 60s, it's hard to believe that, we lived through those times. But I wouldn't trade them for anything.
Well, you guys did it. You're what we call national treasures for what you've done to change the complexion of whole society. You better believe that, folks. This is the shuttle era, particularly launching over 300 astronauts, building the International Space Station, making access to space pretty common, fraught with danger and its unknowns always. And in fact, this 41G mission came back with some tile problems for sure. You go back and look at the history of it there. There were some tiles that had dropped off. That was a very dangerous situation that they didn't know about. But and of course, do you ever go out to the Kennedy Visitors Complex and look at the beautiful Atlantis on display out there?
Oh, yes.
Damon?
Yes. Oh, yes. It's amazing.
What does it bring back to you when you see
I
that?
see the tile. And, you know, they still have their scorch marks on them. So I think it's just an amazing display.
It is. It is. Mikey, what have you got to add to end our program today?
Nothing. It's like I just mirror what Damon says. It was an amazing career. Again, we were in our 20s when we did this, early 20s, you know, right out of college, and you get this missions like this that you get to work. It was amazing. I just loved every minute of it. Wouldn't trade it for anything.
Well, we can't wait to have you back, Mikey, and hopefully have you back, Damon, to talk about Shuttles of November.
Yes.
And I've not racked up all of our flights in November yet, but I know we'll have some interest in flights in there. You probably glanced at a few of them there.
Yeah, there's one in particular. See if we can maybe get.
Which one you
Think
looking
about
at?
Space Lab 1.
Okay.
Space Lab 1.
Is John Glenn's last flight STS-9?
No.
John,
Yeah,
I mean, John Young. Yeah, John Glenn.
Yeah, he was
John.
the commander. Yeah.
Yeah.
So that was the big one. That was the first Space Lab that flew, and so we maybe try to do that
Good.
next month.
Yeah. Well, anytime we talk about the great John Young, I'm all for that. We even have people come in on a tour from Orlando and don't realize that the John Young Parkway over there in Orlando is named after our wonderful astronaut hero, John Young, veteran of two Gemini, 2 Apollo, and 2 shuttle flights, moonwalk on Apollo 16.
Mm-hmm.
And he really was very vocal during the shuttle era also about the safety
Yes.
things on there. So, well, guys, I appreciate you spending your time with us and all of our friends out there watching Stay Curious. Thank you for watching it, Marty. Thank you for a great Streamlabs job today. Anything we need to button up on your side, Marty?
Nope, good.
All right, thank you. And tomorrow we'll have some more shuttles of the month of October, a little bit of space history, and yes.
I can give you 2 more names.
Yes, Angela Butler and Denny Noah there. Thank you for watching Stay Curious today. So, thank you, Damon. Thank you, Mikey. And on behalf of our museum here in downtown Titusville, just 9 miles away from Kennedy Space Center, I'm Mark Marquette saying I can't wait to see you again to bridge the space between us.